We have looked at drawing histograms in a different recording. Here we will look at interpreting histograms. So again, what's the most important thing to remember about a histogram? It is the area of the bar tells us the frequency. Okay, how many students attend the college? Well, since the area of the bar tells us the frequency, we need to work out the area of each of these bars, which are rectangles. Okay, so for the first one, we've got a base of 10 and a height of 15. So 10 times 15, 150. The second one, we have 5 for the base, and the height is 28. So 5 times 28, 140. Here we have 5 times 35, 175. And for the bottom one, we have 10 times 10, 100. How many students attend the college? You need to add up those 150 plus 140 plus 175 plus 100, 565. Okay, so how many students live less than 10 kilometres from the college? Well, here's 10, less than 10, 150. How many students live between 15 and 20? So between 15 and 20, 175. Estimate how many students live more than 25 kilometres from the college. Okay, so this is estimate. Why did it say estimate? Well, we know 100 people are between 20 and 30 kilometres away, but we don't know exactly how far. But we're going to look at it proportionally, and we're going to say it's half of the bar. So it would be half of 100. $50. And how many students live less than 5 kilometres away? Again, it's half of this bar from 0 to 10. So half of 150, 75. Okay, so I just don't want my bars to be too busy, so I've just got a new histogram here. Put all the frequencies in the bars. How many students live between 5 and 12.5 kilometres away? So there's 5 and there's 12.5. So it's half of this bar and half of this bar. It's half of 150 plus half of 140. So 70, add 75, 145. Estimate how many students live between 12.5 and 17.5. There's 12.5, there is 17.5. So half of 140 is 70. Now half of 175 is 87.5. Because we're dealing with people, we're just going to round that to 88. So 88 plus 70 is 158. Got to have a whole number of people. Okay, between 10 and 14. Okay, this is where it gets a little bit more complicated. So here's 10. Right, now where's 14? So let's just look at this scale on the x-axis. We've got 10 little mini boxes here represents 5. 5 divided by 10 is 0.5, so it's going up in 0.5. So 2 bars will make 11. Sorry, 2 little boxes will make 11. So 14 would be up to here. Now, what proportion of the bar is that though? It's not half, more than a half. What is it exactly? Okay, so between 10 and 15, we've got 5, right? And between 10 and 14, we've got 4, so it's 4/5. So we're looking at 4/5 of 140. So 4/5 times 140, 112. And the next one is between 8 and 16. So 8 be 5, 6, 7.5 here, 8 be here. And 16, which should be here. Right, so we've got all of this 140. And then we've got that proportion of that bar. And this proportion of this bar. Okay, so we've got what fraction of this bar do we have? Okay, well, it's all out of 10. Here's 8, right? So between 8 and 10 is 2. Between 0 and 10 is 10, so it's 2/10. And then here, that's 16. So we've got 1, because 15 to 16 is 1. And 15 to 20 is 5, so we've got 1/5 there. So we need 2/10 of 150, which is 30. And we need 1/5 of 175, which is 35. So for I, we have 30 plus 140 plus 35. 205. Okay, estimate how many students live further than 16 kilometres away. Okay, so we've already got 16 measured off on here. So we're looking at all of this and all of this. Right, so between 16 and 20 is 4. It's 4 out of the whole bar, which is between 15 and 20, which is 5. So 4/5 of 175. 140. So 140 plus 100, 240. Okay, let's look at some exam questions. I've got a few pages for you to look at. So for each question, put me on pause, have a go, and pause when you're done. So the table shows information about the time in seconds taken for some people to run a 100-meter race. We use information on the table to complete the histogram. Well, what do we actually have here? Let's just put our information on our diagram. Between 16 and 20, it's the frequency of 8. So the frequency is the area, so the area is 8. Okay, so we're going to have to use that information to work out our frequency density. So frequency density is frequency divided by class width. So the class width here is 4. So 8 divided by 4 is 2. So we know on our bar chart that this here is 2. So each 2 mini squares is 1. So we'd have 5 here. And this would be 21. Okay, so we know the frequency density is 21 here. That's the frequency density. That's the height of the bar though, not the frequency. Class width is 2. So how do we work out the frequency? Base times height, 2 times 21, 42. We're just rearranging this formula. We could have rearranged the formula, but we know, don't we, that the area of the bar is a frequency. We could have rearranged this. Frequency density is 21. Frequency unknown. Class width is 2. 2 times 21 give you your missing value. Okay, well now we can draw the rest of our histogram. So 6 divided by the class width. 21 divided by 1. 23 divided by 1. So here between 10 and 12 is 3. Between 12 and 13, 21. Between 13 and 14, 23. Okay, so we've got a histogram that's already drawn, a table of information. So let's just see what we have here. 40 to 45, nothing in the table. 35 to 40 has a height of, well, a frequency, sorry, of 42. Frequency is the area of the bar, so this is 42 in here. So we know that the frequency density is frequency divided by the class width. So 42 divided by 5, 8.4. So this is 8, 2, 4, and 6. So if you can see here, we're going up in 0.2s, so 8.2, 8.4. So what you could have done there is you know that height is 8.4. There are 10, 20, 30, 40, 42 mini squares. So 8.4 divided by 42 is 0.2, which shows it's going up in 0.2s. Okay, let's finish drawing our histogram. Let's get our frequency densities. 15, 10, 5, 15. 12 divided by 15, 0.8. 28 divided by 10, 2.8. So we've got some information missing here, but we have our bar. We know the frequency density for 40 to 45 is 6. So 5 times the height is 6, 30 for our frequency. And 15, nope, 9 divided by 15, 0.6. So we have between 10 and 25, 0.8. 25 to 35, 2.8. Forty-five to 60, 0.6. Okay, question 6. 30 pigs weigh between 50 and 65. So that's 30 because the area of the bar is the frequency. Work out an estimate for the number of pigs which weigh more than 80 kilograms. So from here all the way to here. Right, we don't know the frequency density, so we can't work out the area of any bars. So let's work that out first. So area, frequency divided by class width is frequency density. So 30 divided by class width between 50 and 65 is 15. 2. So the area of these bars now to get the frequencies. So 5 times 6, base is 5, height is 6. 5 times 6 is 30. 5 times 8 is 40. 5 times 4 is 20. I could have worked out the whole bar in half. I'll probably do that actually. So 10 times 4 is 40. Whole bar is 40, so obviously half of it is 20. And then 15 times 1 is 15. So we've got 15 plus half of this bar here, which is 20. So we've got 35 pigs. Explain why your answer in part A is only an estimate. Well, we are using group data. We don't know how many pigs weigh between 80 and 85 kilograms. Okay, so our GCSE at Excel do quite like this type of question here. Work out an estimate for the proportion of plants over 25 centimetres. So when we're asked for a proportion, it's like a fraction. So the fraction of plants which are over 25 centimetres. So we can actually just guess the frequency density. We'll just make it into some nice numbers. Because it doesn't matter what you use. I could use this as 1 or this as 10 and we would still get the same proportion at the end of it. So I'm going to label 1, 2. If you want to do it a different way with the same question, you'll be able to see we get the same answer. So let's get the areas for all of them. So 10 times 1.2, 5 times 3.2, 5 times 4.4, 10 times 1.2, 20 times 0.3. Okay, so how many plants are there altogether? Let's just add all these up. So we've got 68 in total. 68 plants. How many are over 25 centimetres? So over 25 is from here all the way to here. We've got half of this bar and all of this bar. So 6 add 6 is 12. So the proportion is 12 over 68. which would all our answers were simplified to 3/17. Either of those answers are fine.